Okay, welcome back. In this module we're going to be opening up SPSS, working in there and looking at all of the variety of t-tests that are available to us for use. So if you will open up SPSS, click on the Analyze menu, and we're going to go to Compare Means. And as you can see, there are several different tests here that are labeled t-tests, and those are the ones we're going to be working with in this module. The first of these is the independent samples t-test. Now this is going to be very similar. Let me just clear these out real quick so we can do it together. This is going to be very similar to the t-test that we ran last time. However, if there is an assumption that is violated by this data, the t-test, especially the group amount assumption, so if you have to have like the same level of items in the same level of participants in each group, that's not really an assumption, but it will use the correct formula in that case automatically. So our data will be slightly different than the data we calculated in Excel, simply because of that. So we'll go ahead and run this real quick, and we'll see how SPSS deals with the violation of how it will deal with a violation of the homoscedasticity assumption, as well as handling our issue potentially with the difference in participants in each group. So we'll just move gender over to the grouping variable. Then you have to define that. Remember, males are 0 and females are 1. Other was 2. However, we can't quantify them in a t-test. A t-test can only use 2 groups. So we'll just go continue, and then we want to have the political violence in the test variable. You can move more than one over in here if you would like to run more than one t-test with the same grouping variable at one time, but in this case we don't need to. Go to options. You can change your confidence interval that'll be calculated with it if you'd like, and how you want to manage any missing data, but we won't need to worry about that. So we'll just click OK. As you can see, this pops up pretty quickly. We've got our group statistics, so it gives us the N for each group as well as the mean and standard deviation. You'll recall those are the same as was calculated last time in the Excel spreadsheet. This is the box that actually deals, this lower box actually deals with the t-test in particular. SPSS runs a test with each t-test, and as well as with a basic ANOVA test to see if the variance is equal across the group. It's called a Levine's test for equality of variances. And this test, the null hypothesis of this test is that the variances are equal. So if this is a significant test, if this value is significant, then your variance between your groups is not equal. In this case, it is non-significant. So we have the same variance across our groups. That means that all of our values are going to be from this top row here. So as you can see, our t-score is 3.57, our degrees of freedom are 94, and it is a significant difference. So in this test, again, is different. The score from this test is different from what we ran in Excel because a formula was used that accounted for the difference in sample size, in a group size, that we didn't do. It's a much more complicated formula, so we didn't mess with that. But that's where the difference comes from, and as you can see, we get a different score. It is a lower t-value, but it's still significant. If, for instance, our equality of variances test did prove to be significant, we would just simply use the second row as our actual data. As you can see, it varies slightly. We have a different degrees of freedom. Our t-score is ever so slightly lower, but the end result, the test is still significant. So regardless, this difference between means between men and women on acceptance of political violence is a significant difference, and men are generally accept more political violence according to our population. So that is all fine and dandy and good to know. Now this is the between subjects t-test, independent samples t-test. So this can only be used if male and female, if they're not the same item. So if we had a time 1 and time 2 that were the same participants in each time, we could not run this test. However, there is another test in SPSS that we can run to do that. So that's very simply again an analyze compare means paired samples t-test. In this case, a different box will pop up, and you would then you would have to divide your different scores at time 1 and time 2 into different columns, so you would have a different variable for each score, so to speak. So let's say PV10 and PV11 were taken at time 1 and time 2. We would just pop these over here like this. So we want to see the difference between these two scores that are the same participants. We can go to options, that looks fine. And then you're going to see a very similar output where there is no test for the equality, or Levine's test of equality in this case, so you just have to follow the assumption that your variances are equal. They should be. You should be running the same sample size if it's a paired sample. It would look just like this. As you can see, it gives you a correlation to show you how they're correlated and whether that's significant. It gives you the mean, just like we had before, and there's the t-score, the degrees of freedom, and the significant difference between those two groups. In this particular case, it doesn't mean much because these two variables aren't what we would run from a paired sample difference. But if we had the same scale, like if we did the political acceptance of political violence scale twice on a pre-test and then a post-test, and then had some manipulation in between, we would run a paired samples t-test on those 2 times to determine if there was a difference. That's how you would do that. And it would look just like this. You would have your means, standard deviations of each group, your t-score, and then your degrees of freedom and significance. And that's how that would look, and that's the way you run that test using SPSS. Also in SPSS, there's a way to do a one sample t-test. In this case, you run a test variable against a specified value. So if we want to look at political violence again, and let's say we want to see if political violence is in the whole is different, statistically different than the score of 3.0 on that scale. So for some reason or other, we want to test if this score is different from what we would expect a 3.0 in the larger population. We can go to options again. That's just the same of what we want. And we click OK. And as you can see, this is very similar to our other scores. It gives you the mean, the end, standard deviation, and here you can see the t-value, the degrees of freedom, and whether the test is significant, comparing this mean to this value. Those are very close, so there obviously is no difference. So that is how you run the t-test in SPSS in various different ways. We went through the independent samples, the paired samples, and the single sample t-tests. We talked about how to handle homoscedasticity violations using the Levine's test of equal variances in the independent samples t-test. And that's really the only violation that we particularly need to worry about. SPSS handles all others for us pretty handily, unless there's a normality violation within our scale, like if, for example, the political violence scale was highly not normal, in which case we would transform that variable. We would go to transform and then compute into the same variable, or compute a new variable based off the old one, and we would do like a logarithmic transformation or something along those lines. That's another way to handle a violation of normality. But we'll get more into those issues when we talk about regression in general. And the t-test is pretty robust to handling violations of normality. You would have you'd have to be severe violations of normality for it to have any issues. So that's it for this module. I will see you in the next one when we talk about the one-way ANOVA test.